Well, welcome everyone to today's webinar. We're excited to have you with us for this 5-axis milling and kind of the PowerMill Autodesk Power Solutions webinar. If you have any questions throughout the presentation, feel free to drop those in the Q&A section at the bottom of your screen controls. We will also have a dedicated question and answer time at the end, and the session is being recording as well, so we'll make that available to you. Joining me today are Mark Wietrich, who is a business development manager here with NexGenCAM, as well as Stan Akers, who is our technical applications manager. So with that, I'm going to pass things off to Mark.
Good afternoon. Yes, this is Mark with NexGenCAM. We're going to be jumping in to a lot of items here today. And here at NexGenCAM, we understand each customer is founded on their own success. We acknowledge that and we adapt to our customers' expectations. These awards listed here, we understand that it sets the bar high if we're going to be sharing these awards. We understand that we want to come alongside you and make you just as successful. Winning the award this year on #1 service partner in training, support, and post-processors. We want to continue that success and work with you. #1 CAM partner means winning that award by customer retention. So customer feedback is really big on winning an award like that. And then we continue to be a gold partner in our Autodesk Training Center. And so that's our ability to train on over 50 courses today. Autodesk is a large company, and that's a good thing because we can leverage them as a resource and NexGenCAM as our tech specialists to assemble a team and work for you. The name subscriptions has been very successful. It's a dynamic platform that works well on licensing, and so being a top partner with Autodesk, we're able to name those people that can work up a solution for you. Today, we are going to get into these items and getting started here, we're going to discuss industry trends and look at Autodesk solutions set up to address and surpass the needs in the marketplace. We'll then look at each of the Power products at a high level. Lastly, we'll show an example of all 3 products working together in a workflow for Electrodes. Here are 4 benefits that are with PowerShape, one of the 3 Power products. So flexibility, right? Manufacturers often serve diverse industries with different modeling needs. Customer data consists of services, solids, and triangle meshes. End users need CAD tools capable of coping with multiple data formats from a wide variety of systems. Jumping into the performance category, most customers start with finished product design. Converting these models into molds, dies, tools, and other manufacturable parts is critical to business success. Parts must be prepared to be manufactured, including sufficient taper, shrinkage, and allowances. Engineers need tools to help create parting lines, split surfaces, cores, cavities, slides, and lifters. Modeling tools should not delay the start of manufacture. However, the successful manufacturers start cutting chips sooner. Jumping into the CAM integration, manufacturing engineers need modeling companion tools to support CAM programming. Geometry needs will vary throughout the manufacturing process, such as reference surfaces, boundaries, capping surfaces. CAD modeling needs to be agile, flexible to react to different needs. Shop floor CAM programmers need to create geometry without relying on separate CAD designers. In incoming data, manufacturers serve customers with many different CAD systems. Impractical to buy a seat of every CAD software. Essential to import from all mainstream CAD systems. CAD modeling is an essential part of manufacturing, and it's susceptible to faulty or missing data. Also parts modeled that are hard to manufacture, such as an insufficient taper or sharp internal corners. Unforeseen or late revisions to customer designs or requirements also are related to having the proper CAD modeling. Customer models often provided early in the process are not quite finished. The quality of customer data has a huge impact on delivery timescales. Any time spent fixing important data impacts the process in the manufacturing. Here in PowerMill, a lot of benefits also here. We're going to name the top 4. With greater complexity, suppliers or customer goods strive to make their products different and highly competitive in a highly competitive marketplace. Customers have grown to expect new and better parts more frequently. End users expect products that are stylish, connected, desirable, life-enriching, customizable, reliable, and convenient. This places an ever-increasing pressure on the capabilities of manufacturers to react and remain ahead of the product designers. Parts cannot be handmade or half-made, and so CAM needs to provide tools to get the jobs done. Jumping into increased precision, customers' expectations regarding quality are higher than ever. Manufacturers need to maintain extreme levels and high levels of standard with quality and precision. Dimensional precision and surface finish are at a paramount today. Manual polishing is not always acceptable. In control and flexibility, manufacturers are under pressure to make every second count. Component manufacturing needs to be agile to react to design changes. Lastly, new technology. Manufacturers have invested in new and more complex CNC machinery. Your investment is new and needs to have the adequate cutting tool technology. CAM software that can create best programs to drive CNC machinery. And overall, you need to have your ROI. Also jumping into a few more benefits with PowerMill is performance. How do you increase your ability to maximize your machine? Speed cannot be the only consideration. You need speed and quality must go hand in hand. You like with polishing, you don't want to do manual rework. You want to have a complete part at the machine, so there's less setups between jobs. And the confidence going forward. It's important to have complex parts that inherently work in manufacturing space. Manufacturers are under pressure to produce high quality, reliable NC code. Programmers' errors can be disastrous, resulting in damage to parts, workpiece, fixturing, or CNC machine tool itself. So jump into the next Power product. As PowerInspect, it's essential to close loop when ensuring that a part is adequate. Errors in part programming can create the need for model rework. Manual programming or existing CAM software does not produce the results you need. The inability to capture and reuse programming knowledge between jobs creates inconsistency. Let's see how all 3 of these products work together. They all come together as a complete solution. These are all very well supported by NexGenCAM, not only from support, but then giving you success in training. Let's hear how these products can what they can do for you. Here is Stan from our team to talk next.
Thanks, Mark. I'm going to go ahead and share my screen here. Once I get my slide deck up, sorry about that. Let me jump into my slide preview here and pull my Zoom back up. All right. Share both my screen, that one. Okay. Should see my screen.
Yep, you're good.
All right, cool. Yeah, so like what Mark was saying, the synergy between all three products are kind of what we're looking at focusing here in this webinar for the most part. When we look at PowerShape from the design standpoint, to start things out here, what PowerShape is really, it's a standalone CAD product, all right, that really is more like a tribrid modeler. It takes the environments of solid models as well as advanced surfacing design techniques and technology, and then as well as a mesh model environment, and combines them all together and gives everything your shop floor needs, all these tools all in one software to be able to manage the more complex things. And we see that in situations in manufacturing, particularly when we're looking for prepping for CAM itself, or if we look at creating electrodes, electrode design, all the way from the states of the design through to exporting these into your CAM solution. In this case, we're looking at PowerMill. And PowerShape itself works directly with PowerMill. It's kind of its CAD platform. Now, a lot of users kind of look at that from the standpoint of, why can't I have a one solution in one place? Having these split between two different softwares allows you the flexibility, not just to deploy it and use it in different locations, but also the ability to kind of focus on that portion of the workflow, right? So separating the need for one seat to kind of do it all, you've now got a seat of your CAD software with PowerShape that allows you to do the more advanced things and then bring it into the PowerMill environment. If I take a look at what kind of PowerShape is focused on in general, right, we could take a look at this from the standpoint of modeling from CAM, of course, which gives us the solids and the advanced surface features in a direct modeling kind of environment that allows us to go into extending surfaces with ease, trimming surfaces out, directly deleting surfaces or solid components or features that we don't need inside of the model to get to our CAM state for CNC programming. Now, if we think about that from the 5-axis standpoint, we do this quite a bit. Oftentimes when we move from 3-axis in the 3-axis world into 5-axis, we find ourselves needing to create supplemental geometry to either limit where our machine tool is going to be cutting within specific features, or to add surfaces to guide, I would say, like our tool axis and all of our kinematics of our machine tool for our programs, right? And that all falls into modeling for CAM. A lot of times this isn't something that we handle in the engineering department due to its complexities and the need to know the intricacies of the CNC programming workflows, right, out at the shop floor level. So PowerShape really lends to the ability to do this, coupled within PowerMill. If we look at it from the reverse engineering standpoint, really all of the mesh tools that are inside of PowerShape allow us to do things like take scans or even inspection scans. And we'll see that with the synergy and the linkage between PowerInspect as well. This gives us the ability to take those models, clean them up, tie all the solutions together, utilize those STL or mesh data files to be able to guide toolpath, or even to create surfaces out of, to be able to get more accuracy out of our CAM in our CNC programs. And then as well, to be able to use those models for references for things like our stock models or our blocks, right? Inside of PowerMill, we use stock models and blocks quite a bit to limit where a toolpath is going to machine, and then also to increase our accuracy of material removal so that we don't have problems in downstream processes, right? Being able to simulate these things both in the CAD environment and the CAM environment and control that geometry is kind of where we look at like PowerMill helping and lending within the 5-axis realm, right? So if we look at this for the reverse engineering portion of it, just being able to have those mesh tools and bring in, say, your mid-process CAM, especially within a complex 5-axis part, into PowerShape and utilize the reverse engineering tools, helps us to be able to use that design at the shop floor level and then continue our machining processes more accurately without having to stop processes in the middle of the machine time. For the molded tool industry, we see this quite a bit. With PowerShape, though, there's also specific wizard-driven functions that allow us to do specific designs, applying more complex features into assemblies and allowing us to use standard components to build our mold and tool designs. One thing we know that PowerShape really excels at is our surfacing capability, and that capability allows us to very easily select and trim edges. They may not actually be part of the model itself from the design workflow, from the engineering standpoint down, and allows us to utilize that geometry very flexibly just by direct interface and being able to pull surfaces out or create curves where there might not be curves and guide those along surface geometry. PowerShape is really excellent with that. We see this in the electrode world quite a bit, right? Electrodes are one of those things that can be handled in the engineering department, but oftentimes what we find out that will happen is once it gets to the shop floor, we're finding that the engineered or designed electrodes might actually need a little bit more engineering to them to get them to manufacture properly. With PowerShape, that's ease of use in the electrode world, from concept of design all the way through into PowerMill for manufacturing, is actually a workflow that is so easy to learn and do that we find that our customers are just doing this out on the shop floor and forgoing the time spent in the engineering department, where now engineers may actually just color code their models in specific regions that they know are a problem, and then bringing that down to the shop floor level where the shop floor CNC programmers for the electrode workflows actually can then take that surface knowledge, surface selection, and then actually apply it to the electrode design, but then also appropriately apply all the clearances and necessary geometry they need to support the electrodes themselves. So we find a lot of time that's actually saved within that workflow. If I look at some of the features here and just kind of explain with the little videos, these little videos that are happening here on the screen, we can kind of see each one of these three specific items, such as surface modeling. You can kind of get a small preview up in the left-hand corner of some of the surfacing capability that you can see here as it goes through kind of extruding a simple surface just based off of a single edge selection. We also find what happens inside of surface modeling. A lot of parametric design and solid modelers don't actually have the complex technology to be able to grab the inside portion of those surfaces, like the ISO lines, and be able to properly align them and pull them into a specific region to give us like the runoff geometry that you see in the mold in the left corner. The center picture that we've got going on now is our direct solid model editing, right? Just being able to select solid features and then adapt them to specific needs so that we can maybe help our cutters spend a little less time cutting unnecessary geometry for a specific operation. Just be able to select those features and maybe delete them or push-pull them to make them thicker for a first operation versus a final op for a finish. That power, the ease of that power in the right hands on the shop floor can save you a lot of time and a lot of tool cost. Finally, we kind of look at our mesh modeling kind of environment within PowerShape. This is actually showing kind of a picture of a scanned data mesh model that we've got here. And this is a little bit older picture of PowerShape, but you can see here that we have the ability to just simply create and pull edges off of mesh data and then create simple surfaces to which then we can use to either split core cavities for specific tooling or even fixturing for that matter, and then utilize that data to guide tool paths as well. When we look at preparing complex models and importing those models for CAM, some of the problems that we have is directly within import. PowerShape as well as PowerMill is kind of in the background using our Autodesk manufacturing data exchange engine, which can basically take any CAD source, bring it in, and then interpret it into the PowerShape model to be able to be used across the entire platform. And then you can pretty much do anything that you want to do with it. One of the things we do find within importing models is the ability to just take that model and then use the solid doctor within PowerShape, or even use some of the analysis tools within PowerShape to kind of correct some errors that happen on translation. Many CAD systems out there have specific tool sets that they've developed that don't generically transfer across platforms. It's very important that you have your shop floor have the tools to be able to accurately import and recognize features, as well as maybe recognize where those features are missing within the model so that you can accurately take them through the manufacturing process. That all happens within the model preparation, which also PowerShape gives us tools such as splitting core cavities or extracting surfaces from the sides of our models to be able to find split lines for tooling, or even to rest a very complex surface onto a fixture component. Being able to extrude those out, give yourself the workspace that you need, or even the extra data you might need to create toolpaths is very important. So we find PowerShape kind of fitting that need. Finally, if we just look at it inside of the CAM realm, if we take our models from CAM back into PowerShape, we find ourselves doing things like capping surfaces or creating extra guide curves within the model to be able to just use as reference geometry for the toolpaths, right? Oftentimes, especially with like rib features or more complex things, we're capping ribs. Having specific set tool sets for that for your shop floor to use is very important. It's not often that we would have the technology on a shop floor to be able to just go back in and maybe roll a specific design back without being able to, or forcing us to disrupt the engineering workflow in some way, or alter the model to a point where we're having to save multiple versions of that data in one place. Having it a little bit separate, we found both through our customers and then of course by personal use, I found that separation between those two models and the processes is oftentimes necessary to maintain organization across your designs. Finally, jumping into PowerMill real fast, just as an overview for those who don't know about PowerMill and its capabilities. PowerMill is a very high-end CAM software, right? And it's directly coupled with the power solutions that we're talking about here in the workflow. So just talking about PowerShape on the CAD side, looking at PowerMill here. Of course, PowerMill has always been a contender for some of the best quality toolpaths in high speed. We also have capabilities within additive. Turning when it comes to the larger mill style turning. So if we're actually looking to profile on a milling machine and turn with your milling machine C-axis, those are capabilities that PowerMill does have. We also look at it from the 2D standpoint for feature recognition and direct, I would say, toolpath onto the model. PowerMill is a CAM solution that sees every single surface as it is, takes that into consideration, and then applies technology within the toolpath for things like collision avoidance and gouge check. And we see that as far as being one of the top in the industry as far as collision avoidance and gouge checks, even protection of your tool when it comes to applying itself to your stock and your model, right? We also have capabilities from the 5-axis side that have been industry leading for decades. PowerMill has always been one of the best solutions that I've ever used as a professional in the programming field. From the standpoint of quickly coming in, getting 3+2 set up, but then moving into the full 5-axis realm and having all of the information and data that I need to very quickly and easily set up my full 5-axis motion and have it predictably and reliably post out code every single time. 90% of the time, what I see with PowerMill on the screen is what I'm going to get when I get it out to the machine tool. And that gives me that peace of mind in my process. We also have the capability of controlling robots. So it's not just 5-axis. We get into like more or less what 7 to 9 axis capability or something like that with robots. I'm not the robot expert myself, but knowing a little bit about it just within the PowerMill environment, I can tell you I've seen some pretty impressive things within robots. So if your organization is looking at robots, PowerMill is definitely a solution that can help. If I think about PowerMill's capabilities from the 5-axis side, what we get, of course, we get our increased precision, but that comes down to the simplicity of being able to just place work planes where they're necessary and using them as work planes, right? To be able to tilt into our 3+2 position, guide our machine tool, and know exactly where that's going to go before we get down onto the shop floor. Excellent surface finishes is something we've always excelled at with PowerMill. We have the capability of going down into microns within our tolerances and then accurately sending that data out through our post processors. As long as the machine tool is capable of doing it, PowerMill can actually drive that. Greater efficiency with our toolpaths. We've always been kind of number one with our calculation speeds. We kind of pride ourselves in the speed of the calculation of the machine tool of the toolpath, especially over large models, right? We have the ability to really process toolpaths fast, and you get a clean toolpath with predictable results every single time. So if I look at the delivery out to the machine tool, right? So stock simulation are tools that we have inside of PowerMill in many different varieties that allow us to be able to accurately see between operations, right? We're able to see the transitions from one operation to another, from our semi-finishing all the way to our finishing. When it comes to roughing, we're able to section those planes out and give us accurate simulation data so that we can predictably know how much material we need to remove on the downstream processes. All this happens within the toolpath calculation, along with collision avoidance to protect your tooling and also predict whether or not you're going to have issues within other processes that might break your tools, right? So some of the tool sets in there that we use quite often with PowerMill, we call it the PowerMill workflow. That's our ability to calculate a toolpath within the entire model regions, but then go ahead and do things like trim the toolpath to specific needs in specific areas. The picture on the top right corner, you kind of see you've got some red and green toolpath, but what we could do is we can calculate a toolpath that gives us a successful toolpath, altering its lead ins, lead outs in specific positions, but also just utilizing what we want, trimming the toolpath within that region, and then going through and optimizing the cut moves after the calculation without having to recalculate that toolpath is one of those powerful things that we can do in the software. 5-axis optimization, and what we kind of look at with 5-axis, some things that we need to do is be able to actually directly control that 5-axis and the kinematics from the machine tool. PowerMill gives us these tool sets in the software that allow us to use specific guide curves to just do anything that we want to. That brings us back to our PowerShape being a part of the synergy here. We can extract any curve geometry that we need to control the kinematics of the machine, not just reach the geometry, but also affect how the machine tool is approaching that work as well as driven to those surfaces. From there, we can also look at analysis tools within the 5-axis motion in PowerMill. So after we've already created our toolpath, we've created geometry to guide that toolpath, there could be some kinematics motions within the machine tool that may be out at post-process. At that point, we might see things like jerks or fast transition between rotary axis. PowerMill has some analysis tools built into it that allow us to predictably look at that and then reevaluate where we need to smooth that out. And then we can go into things like direct modeling and just grab our tool, rotate it into place, and then smoothly transition where we need to. So allowing us to more sculpt the program versus just write a program and allow calculations to handle the method of manufacturing. PowerMill also comes with some industry solutions that are specifically for things like blades and blisks, impellers, and then also we look at like port machining, being able to guide tools with specific geometry and between specific features allows us to more accurately control whether or not we're going to have collisions or issues in those areas. But just being able to have the tool paths directly for those, they're kind of set out to be guided by the specifically selected geometry and the surrounding geometry of these features. I also want to point out we have impeccable control over our tool axis motion. So within PowerMill for 5-axis, we kind of look at it from the standpoint that the tool in PowerMill is always what is in contact with the surface for the tool path. It is constantly aware of that tip of that tool. It's been one of the industry leaders for many decades as far as conical tip tools, which we see as a trend now that there's more tool manufacturers readily grinding tools with conical tip tools and giving us more geometry to this. PowerMill's always had the capability to drive these tools with the most efficiency as it finds its contact normal and gives us the tool axis control we need to maintain larger step overs and higher speeds and feed rates. Lastly, I think we've got customization. PowerMill's always been #1 in the industry for customization. It's one of the only softwares where you can truly take every single command within PowerMill and structure both your user interface as well as your automation for your toolpath creation any way that you like it. If you can conceive it, PowerMill can do it, and that's why it's called PowerMill, right? But that automation allows us the ability to kind of link things together as well. So we can create complete automated processes that both recognize features, apply our toolpaths, and then also verify and check those toolpaths all the way out to post-processing where the code is just delivered right away to the machine tool. So all of that customization and automation is built into PowerMill as a basic within the PowerMill Ultimate seat. For robot, we have dedicated tools for offline programming of robots so that we can basically do all of the visualizations and checks before actually putting code out to the machine tools. We can see all the kinematics working all at one time. But this gives us the environment to set that robot up to, and then allow us to virtually jog through or alter things as we need to. So there's an ability in PowerMill to be able to take a robot and drive it via the pendant and basically mimic one-to-one what you're going to be doing with that robot. Because kinematics on robots can be, I would say, somewhat finicky to work with, considering that they have multiple ranges of motion and not just the 5-axis limitations that we normally can work around. A robot has more degrees of freedom to work with. So we have all of the tool sets built into our robot plugin that allow us to be able to work with this visually versus having to actually think about those angles or set those that known variable up ahead of time. We can actually go through, write a tool path, apply the simulation, and then take the simulation through its paces to control where that motion is going to go. Lastly, it brings us to PowerInspect. Before we get to kind of our little video demonstration of the Electrode, we'll just touch on a couple of points of PowerInspect. So PowerInspect is kind of the last hub of the wheel here. It is a separate inspection software, but it specializes in driving inspection through all of your quality points, right? So from on-machine tool verification, or even on machine tool setup, if we're looking at realigning our parts on machine tools within processes or between processes, PowerInspect's got suites of tools that allow us to do this based off of the Renishaw or the other probing. It could be any probe for that matter. I use Renishaw just because that's my go-to, right? But any of your probing data that you need off of your machine tool, set that up virtually in space beforehand, post that information out, and then get direct feedback from your machine tool. From there, we can also share that data via reports or even via the program code to other inspection needs, such as CMMs or lasers or even scanners for that matter. So why PowerInspect? You know, again, it's universal. It can be used on multiple devices. So you could have one seat of PowerInspect that actually could be deployed across your machines, your CMM, as well as any of your other inspection devices. You can utilize this and share the same reports, of course, and then also create your own environments for inspection. You get collision and gouge checking out of this, and it's kind of a all-in-one inspection software, right? It's also simple to use from the aspect of, on the manufacturing side, if we look at deploying some of these higher end softwares with this capability, oftentimes we see they're quite complex to use. And you know, we have different splits within our organization often on these equipments, like from our OMV side of it to our CMMs. We oftentimes see that these software complexities can become a bottleneck to our inspection process. Being able to be in one environment and take that data from each process can be a lifesaver when it comes down to very large work or very complex work. So again, just touching on that what PowerInspect really encompasses. So it's a complete solution for CNC OMV, CMM, and as well as portable inspection equipment. That includes pointer devices, not just the optical devices like a Leica laser or anything like that. It can inspect just about anything from your simple, most prismatic geometry all the way through surfaces, but it really excels with that surface data and the readout and the data that we get back from PowerInspect from those surfaces. A lot of times what we see this being used for is like in-process inspection between, I would say, like operations. So for going from one operation to another, and we need to inspect within region to be sure that we've removed all that material, PowerInspect surfacing capabilities allows you to really dial in that specific location and kind of make sure that you've removed all that material within the OMV environment. You can then take that off of the machine tool, and let's say we're going to the point where we're going to marry a tool together. A lot of times what might happen is some material may be left over. If you've missed that material and you haven't detected that material, you're going to bind up on that marry of that tool once you put it together. This happens often with very large molds or more complex tools, right? As we start to assemble our tools, we start to see these areas where things don't quite fit. Well, that causes rework, and then, of course, increases your time in your process in your shop, both going back to the machine tool, maybe having to pull another job off, or whether it's just waiting for that machine to become open. Being able to check that data ahead of time or compare that data across all of your devices in your inspection process is almost priceless when it comes down to that. Just back on the PowerInspect capabilities, just so you kind of see an overview here of what we're looking at, right? So on machine verification, in lifecycle probing, freeform surface creation and inspection, of course, because it works directly within with PowerShape and PowerMill as well, right? Electrode inspection is something that we see this quite often with, as far as from the standpoint of checking between your burn faces, being sure that your clearances are correct, right? It has no-go function just to quickly be sure that you have those clearances and that specific feature is going to fit together or fit within that region, right? There is an option over here on the right-hand side within industry that we find this used quite often, which is the clay milling industry. This is for automotive. So basically sculpting, and in between sculpts, being able to inspect those surface data to be sure that you've got your net shape in place, right? So PowerShape's actually been deployed quite a bit to be able to do that. So lastly, we're going to take a look at just a quick couple of videos here so you can just kind of see the solution tied together from the standpoint of the Electrode solution. So this next video we're going to go ahead and play is just going to go through the design side of it, as well as the programming side of it within PowerMill. And then lastly, we'll pull in an inspection video so you can kind of take a look at the workflow through that. And of course, with Electrode design, these are kind of the steps that we look at through that. So before we jump into the video, we're just looking at it from the standpoint of the life cycle of the Electrode, right? From design concept to manufacturing. Some of the important points that we really got to look into here is the control and the project management of that, right? So it's not just, I've got a design and here's a great solid model, go to town. It's also controlling that process when you're evaluating the toolpaths, having the tools ready and accessible and available, the setups ready where they need to be. So both from the manufacturing side, on the machining side, being able to set that Electrode up and know that you already have the materials and the tools necessary to get in there. So basic structure of the Electrode design, and then also giving burn instructions directly to the EDM department, right?
Or EDM is used to add slots and other small details to molds and dies. These features are often too small to be CNC machined directly, so require the generation of specialised copper or graphite electrodes that are used to burn details into the mould. With a complex die block often requiring hundreds of electrodes, it is essential that the manufacturing process is streamlined as much as possible. Autodesk provides tools to automate the design, manufacture, inspection and subsequent EDM burning of electrodes. The process typically begins with Autodesk PowerShape being used to model the electrode geometry. At the end of the modelling process, PowerShape exports a .trode file. This Autodesk file format contains a detailed definition of the electrode, including its 3D shape, blank size, holder type and spark gaps, as well as information on the exact EDM burn position and alignment. PowerMill provides tools to automate the NC programming of the electrode. Within the software is its own Electrode wizard, which will import the .trode file and use the intelligent data embedded within it to automatically generate the NC code needed to manufacture the electrode on a CNC machine tool. The automation process identifies burn, clearance and blank faces based on model colour templates, and then calculates appropriate toolpaths using predefined tools and settings. Separate roughing and finishing spark gaps are applied to toolpaths, leaving minimal additional programming input. The resulting NC data is automatically exported to your CNC milling machine. As PowerMill utilises configurable machining templates, users can embed their preferred manufacturing expertise into the wizard to control how electrodes are manufactured. Throughout the CAN programming of electrodes, users have full access to the entire suite of toolpath creation, editing and optimization tools, resulting in the freedom to customize the manufacturing process, or EDM, is used to add slots and other.
Whoops. All right, that was the end of the video. I think it was set to loop. But we'll go ahead and play this next video. This next video just goes into the inspection process after those processes of manufacture.
Necessary to include inspection into your manufacturing environment. Autodesk PowerInspect helps you do this, allowing you to measure your parts throughout the production process. Autodesk PowerInspect is hardware-independent inspection software, supporting a variety of measuring equipment from a range of inspection hardware providers. Devices range from arms, scanners and trackers, through to coordinated measuring machines and machine tool probes. Creating measurement sequences is easy, with a range of CAD interrogation tools, as well as free-form surface measurement and built-in strategies. Manufacturing integration is achieved by incorporating inspection and verification into CNC machining workflows, while simulation and automatic collision detection and avoidance allow you to be confident that sequences will run successfully. Automated part alignment can produce a quick, accurate and consistent setup. Part verification, whilst the component is still on the machine, can be used to check accuracy before moving to subsequent operations or final inspection. Unexpected variation can be detected and remedied immediately, minimizing costs and improving efficiency. With clear and accurate reporting, Autodesk PowerInspect provides validation for your manufactured parts, helping you to achieve your quality.
Oops, looks like my video got cut off there. So with that, guys, I'm going to go ahead and hand it back over to Mark. So I'll stop sharing my screen. Mark, are you ready?
Yeah, let's see this. Joy, you want to share yours? Okay.
Okay, I think we're there. Sorry about that.
Great. As you saw, a lot of items, a lot of topics. Hopefully your mind is open to seeing some solutions come about in your area. We'd be happy to talk with you and develop a solution for you. There's ways here to first talk to you, and we want to hear what is going on in your area. So then from there, we could look at providing you a quote. And with that, sometimes there's maybe a statement of work depending on your needs that you may need. So with that, we will, some items there are speed and performance are usually the top two that our customers are looking at. They want their tool paths to be more efficient and they want reduced errors. How do we get the second shift guys trained faster? And so what we do is we sparse this out between your short-term and long-term goals. And that really helps set up expectations for both you and us, so we can be meeting deadlines as you have them today with your customers. By leveraging over 50 classes that we offer on a monthly basis, we'd recommend joining us in these classes, either from essentials, basics class, or into a custom class where you can have a bank of hours and consume them when you need them with us. We continue to grow our library with best practices. And these are items we can provide you within our support package called Platinum. And we'd be happy to kind of assist you with what's the best starting point. Maybe it's training, maybe it's just a conversation. A lot of our customers have gone through this journey with us, and the journeys are short. Sometimes they're 90 days. And so we've had several of our customers that fill out a success story, and it helps market your account your company name, and then also helps us help others. And so these are just a few examples of where we helped streamline their business portfolios and continue drive success for them.
Okay, so we are kind of at the end of the presentation. Stan and Mark, as always, just provided a whole lot of information. So if you are still processing, we totally understand. If you do have any questions that come to mind right now, go ahead and drop those in the chat section and we can get those answered, or just follow up with you, separately if you'd rather. So we'll give it a minute here. Okay, so I'm not seeing anything come in here. And so we did go a little bit long today. So I think I will just wrap it up here. Thank you all for joining us. We will again be sending out the recording of this from today. So if you want to go back and look at that, or if you're just ready to start a conversation with Mark or someone else on our team, you can contact sales@nextgencam.com, or you can go to our website, nextgencam.com. There's lots of ways there to contact us and kind of start that conversation. So with that, thank you again and have a great rest of your day.